Okay, hello. Today I'm going to be going through the most recent Benevolent tournament case called BoEing's 747 with the BEN of BoEing capitalized because this is part of the Ben tournament, in this case by Ben Carr. I'm going to do my usual kind of process. I've pre-prepared my sheets so that we're not wasting any time with setup, but I will try and replicate obviously the questions as they were, and I'll say a little bit about how I got along as I go along. So yeah, all of the information was provided in these tabs. We've got information on delivery windows of different models of 747, when they first delivered, last delivered, and who. We've got orders by year and deliveries by year. We've got orders and delivery by airline and model. There's a Wikipedia article and then a list of what look like random customers, which comes up in one of the bonuses. So that's basically enough. We're coming up to a minute, so let's get started. So level 1, other than the initial 747 prototype, which was used by BoEiNg for 20 years, every other BoEiNg was sold to a customer. Using delivery windows, identify the customer that received the first delivery of each listed BoEiNg. So we'll go to delivery windows. One of the things we actually need to do here is to unmerge the cells, because these merged rows make kind of looking up ranges slightly more tricky. And so all we're going to do is we're going to X look up the model in the delivery windows here and returning the customer. And we get Pan American World Airways for the first one, and we'll just perform that lookup and we're all good. Okay, level 2, using the orders and deliveries by year tab, return the number of orders or deliveries for each specified year and type. Treat a dash in the source table as a 0, which does come up on them. So firstly, delivery and orders by year. So I'm going to name this the range, but I'm going to change this to OD year, just because if I use year, it might confuse it with my function. I can then just grab all of that, Control Shift F3 to name the range. I'm going to go back here. Actually, I'm going to grab these names as well, paste those in here. And so what do I want to do? I want to X look up the year in my order delivery year and return from the indirect of this. Close that, and I'm going to lock my C1 reference, and then I fill that to the right, and I should get this. And then what I'm going to say is, let's let X be that. If X equals this, and then we'll turn that into a reference, whatever that dash is, then return a 0, otherwise return X. And then if I fill that to the right, again, we'll copy that, and so we get a 0. And then what we're going to do is we're going to X look up deliveries on this range, returning from this range, and we get one error. So we'll go to level 40 to see what the error is, and that's because in our table there actually isn't a 1965, so it's outside. So what we can do is we can fix that by saying if we don't find anything, just return 0. And then fill that to the right, and we're all good. Okay, level 3, which airline bought the most of each given class of 747? How many did they buy? If more than one entity bought the maximum number, answer multiple with the plane count. So we go to the orders and deliveries. Annoyingly, these two, the kind of name and the model, were not in the same cell. So what I'm going to do is I'm going to concatenate this and that to give me the actual references, and I'm going to call these, I'm going to give these some named ranges. I'm going to call these the orders delivery models. I'm going to call this range here, not including the total rows, the order and delivers airlines, so OD airlines, and then I'm going to refer to this, the range of the actual sales, as the orders and deliveries. So I'll just call that OD. And now I should just be able to do an index match or something like that. Let's think about this. So which airline bought the most of each class given of 747? So let's get the airlines, OD airlines, and then let's X look up this based on, so we want to X look up the model in the models, so the headers, and return the whole column. We then want to know the maximum sale. So in this case, the maximum was 3. We're then going to filter this list where the number sold equals the maximum. Can accept that question. I'm actually going to go back to the example because I've actually left this on an edge case. In this case, we only have one, so we want to count how many there were, and this is the one mistake I made in the case. So I got full marks apart from this question because I said count. Actually, I didn't use count here. I said rows of this cell, and I forgot to put a hash symbol there because on the example there's only one, and so by pointing this cell on the example, when we go to example 44, if I don't have that hash there, it only gets one. So then my check on the next step failed because I said if this is greater than 1, then we're dealing with multiple. Otherwise, we're just looking at this person. And then what we're doing is we're joining that with a semicolon and the number. We close that. We get Panam 33 for that first one. If I go to example 44, I do get multiple, but if I hadn't had that hash, which is the mistake I made, we'll see the ones that I got wrong. So I got 44 and 48 wrong because I didn't put that hash in. So if I change that to my rows to h4 hash, would have got full marks. So there you go, lesson learned. Level 4. So this was a tough one. I've drawn a little visualization to help explain what was going on here. So we've got our original time window, which we're given. So let's find that. So we're just going to say X. Actually, I'm going to do some named ranges in the windows. So let's call these the, what shall I call this? Actually, let's just call this the delivery models. Oh, let's change that so it's spelled correctly, delivery models. And then we've got, this is the first delivery, FD. This is the last delivery, FD, and I think for now that's all I need. So we're going to X lookup this model in delivery models, returning the first date. It doesn't like that, so what have I done wrong there? That's an interesting... is that because they're different sizes? What have I done wrong there? So, oh, I didn't actually end up naming this first date for some reason, so let's call that FD. Is that because FD is a name, protected name? No, now it's working. Okay, and then the last date is going to be the same. X lookup B1 in the delivery models, returning the last date. So we've got our last date, 1st October 91. So this is our original time window. So we want anything that overlaps. So there's 4 possible options. We could overlap because we're entirely contained within that window. We could overlap from the start and then end during the window, or start during the window and end after it, or our window could overlap completely. And then these 2 outside options are ones where we're not overlapping at all. And what these all have in common, the 4 that we include, is that the start is before the end of the original window and the end is after the start. So if any of those, if those are true, then we're inside. So let's get this right. So we're going to filter the delivery airlines where the first date, so the start, is less than or equal to the last date of our window, and the last date is greater than or equal to the first date of our window. And again, it doesn't like that. It's delivery models. So I've got my models, not the airlines, and we want to count how many there are. So the number of rows in here. And are there any edge cases where there are 0? I don't think there are. Nope, so that's good. That's level 4. How are we doing on time? Just going up to 9 minutes. Okay, level 5. So this was a little bit tricky. So we're splitting up this arrangement to work out the number of seats. So I'm going to use text split on this, and we're going to split by column and by row. So we're going to, will I get this right first time? If I split by semicolon then dash, no, it doesn't like that for some reason. Let me just check. Oh, that's because I'm pointing at the wrong cell. It's actually C1. The first one doesn't actually tell us anything. It's actually irrelevant, and I think I've got these the wrong way around. I didn't do that properly. There we go. This is what we want. Now, what I want to know is the number of seats, which is these 3 numbers, in this case, added up. So what I'm going to do is I'm going to choose cols on this second column. And what I'm going to do is I'm going to count. So normally what I would do is I would take the sum of the regex extract on this, taking any wildcard, taking all of them, times in by 1 to turn it to a number, and we get sum. And then I'm going to turn that into a lambda So X will just be my kind of variable. That's not going to return anything. But now if I say by row on this, using that lambda, I should get the sums, which I do. My multiples are to take the from this original array, I'm taking the last column, and then I'm just going to multiply those together and then sum this all together to get my thing. And I've just realized that actually I think on all the questions there's only, on level 5, there are only 3 different, actually no, some of them don't have different numbers of classes, so actually it was right to try and build that dynamically and not just assume it was always 3. So I think that was actually a good approach in the end. Okay, cool. Let's go on to level 6. Right, this was a tough one. So basically we've got someone who's removing parts of the data, so the orders and delivery, and for some random reason they choose different sizes of array, and we have to work out what's the worst place they could put it, either one that would delete the most data or the most number of orders. So rows and columns. So we need to know how many rows there are in our original array. So the rows of the orders delivery is 95 and the columns is 21. So what I'm going to do is I'm going to create a sequence of 95 rows and a sequence of 21 columns. And what I'm going to do is basically go over all the possible solutions and then find the maximum. I have found since there's a useful birectangle lambda, which I didn't know about, which would have made this much quicker. So what do I need to do for each possible combination? I need to index into OD, and my row numbers will be a sequence of this many rows, in this case 2, starting at the number we've input, and I'm going to lock that based on the column. And then my columns are going to be a sequence of this many columns starting at this one for this first example, again locking that based on the row, and then close that, and we get my sequence, which in the first one is there's a 2 and a 7, and that's it. And then I'm going to sum that and close that off. And if I now make sure that's all locked, I didn't lock the original numbers of columns, but if I do this now I will get some errors when I drag this to the right because we will run out of space. So what we will do is we can basically just say, for this I can just say if error, put nothing, and so when I fill that to the right, we get that once we get to here that our array would spill out over the edge. So it's basically saying we can't bother looking at that. So I fill that down and then fill this down, we get all the numbers possible, and we see there's some kind of a barrier at the end where it couldn't possibly go. And then all I need to do is say the max of that entire range. And in this case, I get 81. And we're all good. Okay, level 7. So level 7, we've got to do a bit of manipulation to work out. We're still doing with this idea of removing rows, but now we're doing it based on models and airlines. So let's find out what our models are. So we're going to text split B1 on the comma as a, we want to spill that as a column, and then for some reason we've got these random apostrophes, so we'll just substitute using getting rid of those so our lookups work. And then our orders is going to be very, very similar. It's just going to be text split on the where is that data sitting? I can't actually see that now. Hold on a second. So that's a spill, and that's in cell E1. So text split E1 on the comma, and we get our airlines. Actually, what I want to do is I want to put this over here because we now need to work out the number of orders that we had for each of these models. So we want to try and do this dynamically because we know the number of models and airlines will change, so we don't want to use anything that's not dynamic. So if I were doing this just once, I would say X lookup the model in the order delivery models and return everything in OD. That would give me all the orders, and then I can sum that. And I get a sum, but now I want to make this dynamic, so I'm going to say turn this into a lambda based on a row, change E4 for the row. That gives me a lambda which won't produce anything until I join it with a by row based on the models, and then we get the orders, and I should be able to just copy this over here to work with the orders for the airlines, and I can probably just change that to airlines, and we get the orders. So those that kind of is all of the columns, that's all of the rows, but now we've got the intersection of the two. So what I'm going to do is I'm going to say, right, let's join the models and let's separate them with a pipe and a version of the airlines that's kind of is a row. We get all the combinations, and then I'm going to 2col those. So we get 4 combinations because we've got 2 by 2, so that's 4. But I now want to just separate out the models as well from the airlines. So I'm going to go text before, and this way I'm basically getting all of the possible combinations. So then I get the 4 models, and if I copy this over, put this here and change that to text after, I get the 4 airlines. So we're now seeing every possible combination. Now we need to work out when these intersect. So now I'm going to do this as an X match because it's a 2D lookup. So I'm going to X match into orders deliveries. Not X match, sorry, index X match. So index into orders deliveries, X match. The first is the row, which is the airlines are in the row. So that's on OD airlines. And then X match the model on OD models. And that gives me our first one, which is actually 0. But if I were to drag this down, we'll start getting real numbers. But we want it to be dynamic because we need it to map over an array. So what we're going to do is we're going to say lambda M for model, A for airline, where J4 becomes model, airline, and model. That won't return anything just because it's not going on anything. But now I'm going to map over the models and the airlines using that lambda, and we get our orders. So then what we're going to do is we're going to say sum this plus the sum of this minus the sum of these, but we want to check whether we're going to get any errors because of zeros. But actually, no, we don't get any errors. So we basically said we've looked at the whole models, the whole airlines, and then minus where they intersect on both. So that's level 7. Right, we're 17 minutes, trying to keep this under half an hour. So let's go on to the bonuses. So bonus 1, which got a mixed response, involved reading the Wikipedia article and how many passengers did Operation Solomon exceed the passenger limit previously held. So basically we've got this 1087 minusing it from the where is it, 674. So 1087 minus 674 because that's 413, which is correct. Using the earliest first delivery date and the latest last delivery on delivery windows, how many days were there in total? So the first is the minimum of the first date. The last is the maximum of the last date. If we just subtract one minus the other, we get a number. But whenever we do days, we always need to add 1 because the way I actually reminded myself in the case was, so if today was the 1st of January and tomorrow's the 2nd of January, if we said that minus that, we only get 1, but actually there's 2 days. So we always just need to add 1. So we get 19408. Paste that there. For each customer in the orders and delivery, this was a tough one. So orders and deliveries tab, I've got the workings up here ready to go. So I've also got the level. So for each customer, consider the 747-400 the most purchased model when its order count equals that customer's highest model level order count. So let's start by going by row OD max to find out what the maximum is. Then we want to say how many of the 400 did they sell, which is this one. Go all the way down. Annoyingly, these gaps means my kind of using the control and arrows doesn't work properly. And then we want to say, is the 400 the highest? So let's think about this. If trying to again do this quick and dynamically. So basically we want to say, is this equal to this? So is the number of 400s equal to the highest? And then we're going to filter the airlines where that was true. And if we look at our list, select all, we've got 18, so we're on the right track. So then we want to know how many aircraft of all other 77 models were purchased in total. So we want to know, so we want to X look up these on the OD airlines and return this total column, which we haven't actually used up until now. And then we want to say how many of these were not the 400. So let's look up how many we were on the 400. So X look up that on OD airlines and return again. Just do this manually. So this is their did something wrong there. Did I select too big a range or not big enough a range? I did. And we want to say the sum of this minus that. And of course, those data, how many aircraft all others were purchased in totals. And I think I just combined those last two steps. And we end up with 415, which is correct. For each of the 100 height and width combination of 1 through 10, find the contiguous rectangle in the customer buy model orders table containing the largest number of aircraft. What is the arithmetic mean? So I'm going to make a copy of level 6. And I'm going to change these inputs to values only so I can select them myself. And then what I'm going to do is create another data table. So I'm going to sequence of 10 and then a sequence of 10 going across. Just move this. And what I want to do is my answer is going to be what's my maximum there. I'm going to data table this, Alt DT. My row input cell is the rows, the column input cell is the columns. And then we've got all of our answers. And then we're just going to say, give me the average of all of those inputs, which interestingly comes out to 2 decimal places, which is what the question asked for. So 116.1.31. And then the last question, list of 12 BoEiNg customers appears on the manipulated list. Each customer name has one letter removed and its remaining letters are rearranged, ignoring spaces and punctuation. Identify each missing letter and enter the 12 uppercase letters in the listed order. So what we want to do is let's put this. So let's just take one of these. So we'll just take Santa as the first example. So we're going to get all the letters. I'm going to regex extract this on anything that is basically a word character. There's no underscores, so that we don't need to worry about the fact that underscores are considered a word character. We want all the matches. And then I'm also going to make that uppercase just to remove any issues with lowercase. And then I want to get a list of the alphabet. If I type A, we know that the the code, because I'm trying to do this without using pre-built lambdas because I managed to do that this time. So 65, so let's go a sequence of 26 starting at 65 and then take the char of those. We get our alphabet. So what I want to then do is concat this and this. But what I want to do is lock that so it doesn't go down. And then what I want to do is I actually want to do the same. I want to regex extract these. Now, I probably could make this more efficient. I think I'm probably repeating stuff that doesn't need repeating. I then want to sort this in order, but by column. And then I'm going to concatenate it back into a string because that's going to show me just the letters in order. And if I swallow that down, we get all the variations. I'm now going to grab all the airlines from over here. I'm going to do the same thing that I've just done there, basically to the, let's copy this, and I need to do the same thing to the airlines. But what I want to do is I'm concatenating, I don't actually need that. No, I'm going to have to build this again. So let's go regex extract this based on any word character. One time, have I been consistent there? Here I used just a normal while. It shouldn't make a difference because by that point I've removed everything, but just in case. So what am I doing? So I want all the word characters. I want to upper them. And then I want to sort them in order, but by column. And then I want to concatenate them. And I want to do that for all of them. And then what I want to do is X lookup each of these in this range here, returning if it finds it this letter here, and something's gone wrong there. So let me just think about what I may have done wrong. So I want to X lookup this in here and return that actually. Yes, I think that's what I want to do. And yes, I find one of them returns an example. And then what I want to do is filter this where not is error on this, and I get Q, and I'll put the data table by pointing to that. So this can be my data table, Alt DT. The column input cell is here. And because I've just got some data tables working in the background, that was a little bit slow, but if I concatenate this, we get the word Queen Forever. And we paste that there, and we're all good. And how are we doing on time? 25 minutes. So yes, definitely solvable in the time. Well, actually, definitely, I think solvable in the time, but I'm not sure, because obviously with the way the tournament was set up, you don't actually know other than your own, you don't know the exact time you got, although you might be able to work it out backwards by looking at those who were likely to get full marks and then working out the points. But for me personally, I took 42 minutes. As I said, the only mistake I made was on level 3, which was frustrating. Just literally removing that one hash cost me those 2 examples, and I lost 12 marks. But otherwise, can't be happier really with how that went. Obviously 42 minutes is not 30 minutes, so how could I have sped that up? Like I said, there is now, I'm aware of, for level 6, a birectangle lambda, which if I import, see if I can get that replicated. So if I say equals birectangle on the orders and delivery, rows and columns are this and that, and then we're just saying sum, and then we're going to max that. We get 81. So we take all of this working and actually do it in that. So much quicker. If I just point to that, yeah, we still got the right answer. So that's probably took me 4 or 5 minutes in reality. So that might have that would have shaved off a lot of time. But anyway, that's trying to think if there's anything else I learned particularly on this case that was useful. Manipulated list trick was something I've sort of seen before, where if you're trying to compare words and strings, you need to kind of sort the letters in order to create a kind of string of those. That was good. Don't think there's much else to say. It was just some good practice. This was a good question to work on, thinking about windows overlapping. And I think that's all I need to say for now. So hope you found that helpful. As always, I find it helpful doing this process.